Hey guys, so today we're going to be looking at an introduction to the unit circle. Um, and so first it's helpful to define what the unit circle actually is. So our unit circle is the circle of radius 1. So that means that no matter where you draw a line from the origin to any part of the outside of the circle, all of those are going to have a length of 1. And it's centered at the origin in the xy plane. The equation for any circle is always x squared plus y squared equals your radius squared. But since our radius here is 1, then 1 squared is just 1. So this is the equation for the unit circle. What we can do is use this equation to show that there are particular points on the unit circle. So technically the unit circle is made up just of infinitely many points that satisfy this equation. And so what we can do is we can determine, first of all, we can show that there are points on the unit circle by showing that when you take your x value and your y value and you plug them into this equation, you do in fact get 1. Or we can determine if points are on the unit circle. So when we plug x and y in, we can see if we get 1. So we're going to go ahead and start off with those two examples. So if we're showing that the point is on the unit circle, here is my x value and here is my y value. So I'm going to go ahead and plug those into that equation. So I'll have my square root of 3 over 3 squared, because that's my x value squared, plus the square root of 6 over 3 squared. That's my y value, and I don't want to write that they equal 1 yet. I have to show that they equal 1, so I'm going to work with them a little bit until they do equal 1. First thing it looks like I want to work with is this exponent that's on this quotient. So I have a division problem, and I am applying the exponent to the whole division problem, which means I can apply it to the top and the bottom separately. You can distribute your exponent here because you don't have any addition or subtraction occurring, so I can do that in this piece as well. So then what we will end up having is square root of 3 squared over 3 squared plus the square root of 6 squared over 3 squared. And when you have the square root of a number squared, your square and square root are inverses of each other, so they cancel each other out. So really I'm left with just a 3 in the numerator of my first fraction over 9 plus a 6 in the numerator of my second fraction over 9. And I get 3/9 plus 6/9 would give me 9/9, which is in fact equal to 1. So I have shown that this point is on the unit circle because I've shown that it satisfies this equation. In this next example, I am given a point and I'm asked, is it on the unit circle? So I'm going to do the same thing. I'm going to plug it into my equation. Here's my x, here's my y. And then I'm going to see if I equal 1. Now, when it says show, this implies that this will work. And so if you got something other than 1, that you probably made a small error. For this problem, though, we don't know if it's supposed to equal 1 or not. We're going to decide at the very end, so we should feel a little more confident with our math for these ones. I'm still going to use the same equation, so I'm still going to do my x value squared plus my y value squared. And then I'm going to see what that equals. I can go ahead and distribute my exponent the same way I did in the previous example. So I will have just do 24 now on top because the square root and square would cancel in the numerator. And then make sure you do 7 squared in the denominator. A lot of students, an error they make here is when they distribute the square, they end up doing 7 times 2. Do not do that. When you're distributing an exponent, it remains an exponent. So you're still doing 7 to the second power, not 7 times 2. So look out for that. And then the square root of 26 squared would just give me 26. And then same thing down here, 7 squared is 49. So I end up with 24 49ths plus 26 49ths, which gives me 50 49ths, which is not equal to 1. So no, this point is not on the unit circle. It would have to be 49 over 49. Point is not on the unit circle. Okay. In this problem, they tell us that there's a point, square root of 3 over 2 comma y, and that it's on my unit circle in quadrant 4, and we have to find its y coordinate. So I know because they tell me that my point is, oops, that my point, why does it not like that part? Is on the unit circle, I know automatically that this point has to satisfy my unit circle equation. Okay, so I'm going to go ahead and I'm going to plug in, I have an x value, and then my y is unknown, so I'll just leave that as a y. Square root of 3 over 2 squared plus y squared equals 1, and now I'm going to solve for this y value. Go ahead and distribute that squared, so I'll get square root of 3 squared is just 3, and then 2 squared is 4, so 3/4 plus y squared equals 1. And then I'm going to start solving for y. So I'm going to subtract 3/4 from both sides. When I do that on the right-hand side, in order to do 1 minus 3/4, I need to get common denominators. So I'm going to go ahead and I'm going to, this is secretly a 1 over 1 right now, and so I need it to become over 4. So I'm going to multiply it by 4 over 4. So then really, I have the problem y squared equals 4/4 minus 3/4, which is 1/4. And then my last step to solve this is to square root both sides. So then I'll get y equals, and then you can square root the top and the bottom separately, so you can kind of treat it like this. Square root of 1 is 1, square root of 4 is 2, and then when you personally take the square root of something, you have to make sure that you include the plus minus, because positive 1/2 squared is 1/4, but so is negative 1/2 squared, and so these could be two answers when you actually take your square root. Now, for our point, we can only have one answer. We can only have one y coordinate, so we have to decide, is it the positive or the negative 1/2 to be, that's our answer. And so the sign, the plus or minus, depends on your quadrant. And so that's where the quadrant information comes into play. If I was to graph just any old point in my fourth quadrant, remember quadrants start the same way we draw angles, right? So my first quadrant would be up here, so this is quadrant 1, here's quadrant 2, here's quadrant 3, and here's quadrant 4. So in my fourth quadrant, if I was going to draw any point in here, so let's say I was going to put a point right there, and you graph, and you actually tell me what the point is, your x value, no matter what, would be positive, right? Because I would be going positive x values, but you'd be going negative y values. So your y values in quadrant 4 are always negative, which means that since my point is in quadrant 4, I know that the correct answer for this problem is going to be negative 1/2. You can just kind of draw this lima bean around your answer. If it helps to put the other signs in your other quadrants, we can as well. So if I graphed any point in our first quadrant, it would be both of my x and y values are positive. In my second quadrant, my x values are negative, but my y values are positive. And then in my third quadrant, both my x and y values would be positive, or excuse me, negative. So the quadrant is what determines whether your answer, because usually your answer you're going to have to square root to solve for either x or y. You'll get a positive and negative choice, and then you have to use the quadrant to determine whether your answer is positive or negative. Let's do one more example of this one in this video. So we're going to go ahead and do the same thing here. So it gives us our point, square root of 35 over 6, comma y. We know that it's in quadrant 1, and we're going to find the y coordinate. So I know it satisfies this equation. I can go ahead and I can plug in my x value, but my y is unknown, so I leave it as y. If I go ahead and distribute that exponent, I'll be left with 35 over 36 plus y squared equals 1. And then I have to subtract 35/36 from both sides. When I do that on this side, this is secretly a 1 over 1, I need to get common denominators, so I multiply by 36 over 36, and I'll have y squared equals 36 over 36 minus 35 over 36 would give me 1 over 36. And then if I square root both sides, my answer would be y equals the square root of 1 over the square root of 36, so plus minus 1 over 6. And then in quadrant 1, sometimes it's helpful to just go over here and like identify which one's quadrant 1. So in quadrant 1, my x values and my y values are positive. So I know my answer for this problem should be the positive y value since my point is in quadrant 1. Awesome. So go ahead and practice and let me know if you have any questions.